Welcome to Flat Earth Debate Live. I'm your host, Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you would like to support the channel, there is a super chat that runs alongside each of these shows while they are live, and there's also a PayPal, Patreon, and crypto link in the info box below the video. Also, below this video, you can get £50 for swapping your UK electricity supplier to Octopus Energy. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show on Facebook and Twitter. One last time, if you're new to the channel or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button to keep up to date with the Flat Earth Debate. Now, we are joined by 10th Man, Neil, Adam, who else we got? Father of a Stolen Child, Arwin, and a whole bunch of people in Discord. So welcome, one and all.
Hello, hello.
Very enthusiastic mumbling. Excellent stuff.
It's breaking into impromptu song.
Oh, I see you trying to trigger my lovey emotions from back in my college days or something.
Yeah. But on the other hand,
there was a lot of sex in performing arts school. I'm not going to lie. That was a bonus. Moving on.
Just acting.
No, I'm not. I'm just definitely not lying about that.
A lot of shagging.
Anyway, let's move on.
Was any of it hetero, Nathan?
It was all hetero for me. Thank you very much, Arwin. I'm nice that you would inquire of such things.
Okay. Just checking.
Just checking
That's
for your own
terrible, Arwin.
for your own fantasy, right? If you want to picture me that way, you're welcome to, Arwin.
No. I'm just assisting other people in that.
Doth protest a little too much, I feel, Arwin. Anyway, let's move on with housekeeping. Any evidence of a physical, geometric sphere-edge horizon, formerly known as Earth curvature?
Not from Nottingham.
Not from Leamington?
It's pretty sad. They're supposed to have curvature, and we can't find it.
Well, you can't get up high enough to see it.
See what?
The curvature.
Well, you don't need to. The math on the radius says that 1 foot high should start at 1.22 miles.
Exactly. There is no seeing curvature.
Nathan,
I have a question.
Fraction into account,
Hold on.
though.
Just 1 second, Darwin. Slave of Christ. Go ahead.
Hi, how's it going, man? I'm happy to be here. I do have a question. So the pressure gradient, right? So Globers always talk about how the higher up you go, there's less air pressure. Is that caused by some sort of, downward pull, or is that caused by, like air pressure, like the heat of the sun?
You're asking how the gases are produced in the first place, or how we have a pressure gradient?
No, not they're produced. Like, is there a pressure gradient? Does that actually exist?
Yeah, there's definitely a pressure gradient. There's less pressure as you go up high. So if you got to the top of Everest, there's considerably less pressure.
What's the cause of that pressure? Is it the temperature? Is it because it's colder at the top of the mountain, therefore there's less molecules bouncing around?
There's just no gas being produced up there, or very, very little. If you imagine how much gas-producing vegetation there is at the top of Everest, there's virtually none, right? Might be the odd tree a bit lower down, but there's very little to actually produce any of these gases in the first place.
Okay.
So in order for them to be there, they've had to be produced at ground level and then expand up to that level. So they've made their way up from ground level. But obviously, given that they're all produced at ground level to begin with, the concentration is going to be higher down low.
Okay, so if I hypothetical, if I take a chamber, like a 100-foot tall chamber, is there going to be more air pressure at the bottom of the chamber than at the top?
Probably not.
Probably not. So it's going to equalize.
I would have said so.
Oh, okay. I do. And then
not
my
very
next
big.
question is like, oh, sorry, good.
I was just going to say it's just not a very big space. Now, when you're talking about going up hundreds of kilometers potentially, then yeah, it gets much, much, much thinner.
I think when
Okay,
we
so-
when we're looking at air pressure and stuff like that, and over these verifiable heights where we're talking up to Everest and that, then I think humidity or the water content has a much bigger role than is probably stated in terms of contributing to the air pressure. It's within that phase transition boundaries where the amount of water diminishes, and I think that has an underestimated role in terms of creation of the gradient over the first few thousand feet, 10,000 feet, etc. It's, I think, probably more involved.
So I debate globetrotters a lot, and they always tell me this, like there's a lower air pressure at the top, and I always assumed like mainstream science always teaches us that it's because of gravity, that there's a lesser gravitational pull at the higher levels of the atmosphere. But I always question this: is this actually true? Right? If there is
I'd
a actual
that
pressure
statement of the top, dude. The way they've led you at the top, they're making a positive claim that there's a top. Now, as far as I'm aware, that's not been shown other than their claim of a vacuum of space. It's not verified very well, though, as it's not documented. We can go to Everest and check it, but all we've got in terms of stratospheres, thermospheres, exospheres, all those is just references, isn't it? Numbers.
Do you want to know the overcome to this argument, the quick overcome, when they start asking about gas pressure gradients? The quick rebuttal is to say, where did you get the gas pressure from in the first place? So they're asking you about a delta of gas pressure, and presumably you're on that conversation because either you or the subject has come up in regards to how can you have gas pressure without a container. That's the question we pose at the very least. So given that we pose that question, I'm not so sure about you, I'm sure you'll tell me in a minute. When they start detailing a delta of gas pressure, a gas pressure gradient, you've got to have the gas pressure in the first place. Now, the reason we ask how you can have gas pressure without a container is because their assertion, their positive claim, is that we have gas pressure without any containment. So they sidestep your question by saying, well, if I assume I've got gas pressure and then push it into a delta of that, which is a gradient, and then ask you to explain the gradient, we sidestep the fact that we've got gas pressure here with an availability of volume, that would be a space that they believe in, called space, outer space, a sky vacuum, with the gas not filling it in line with entropy law. So the question when they ask you about deltas of gas pressure is, where'd you get the gas pressure in the first place exactly? Given that you have a sky as a vacuum, we wouldn't have any gas. To make any examples, we wouldn't have a gas pressure gradient, we wouldn't have any gas at all if the sky was a vacuum. So it's just their way of sidestepping the actual problem that they have, which they can't achieve gas pressure in the first place in the heliocentric model.
But Nathan, we all know the second law of thermodynamics doesn't apply to the atmosphere.
That's correct, because atmosphere is an oxymoron that is only applicable in their model. So on screen, we've got a picture of atmosphere. Sphere-shaped air. Well, air doesn't take the shape of a sphere. It fills the availability of volume it has to fill. Now, in the picture on screen, all of the black area would be the space that this gas has to fill. Now, they're saying, oh no, it just arbitrarily goes into the shape of the sphere it's around. No, that's not what gas does. You're never going to show me a marble in a vacuum with gas clinging to it. It's not possible. The gas will just fill the space. It expands in all directions. All of this gas wants to expand out in all directions. That's all it wants to do. Making this area fake. Doesn't exist. It's not real. It violates natural law. Okay, sorry, go ahead.
Okay, so my question ultimately is it safe to say that, like, if I have a chamber of gas, can I say that the pressure is completely equal in that gas if the temperature is all the same? Is it safe to say that, or is that contradictory to what we believe?
No, it will eventually reach an equilibrium if you've just got a container with no extraneous stuff going on. It's just going to equalize.
Even if I expanded it to the shape of the Earth, like I take the whole Earth and I and there is no temperature changes, there is no strange things going on, is the gas pressure at the very bottom always is going to be the exact same as the top as well? Is that a property of gases?
Can
Go
I
on,
address that a bit?
Yeah, go ahead.
We talk about it being a dynamic system. It is, but there are certain truths that hold true, and one of those is air pressure and altitude. The two are intrinsically linked. Yeah, so you can take the air pressure and say what your altitude is. You can say calculate what the air pressure will be from your altitude. They are interchangeable, and that constant seems to apply all over the plane within very small parameters. But that does seem to be a part of the gradient. Seems to be stable within the dynamic system, which itself I can't attribute cause, just it's noted, but that in of itself wouldn't fit with the vacuum being at the top.
Can I claim
Suggesting that temperature is intrinsic to the whole gradient as well.
I'm sorry, what'd you say?
I think he's trying to suggest that temperature is intrinsic to this gradient as well. That
Yeah,
if there
that's what I'm
wasn't
trying to claim.
a
Yeah.
vary in temperature with altitude, then there wouldn't be a variation in pressure.
Yeah, if there was no, if the temperature was all equal, would we have no gradient? Would it be completely like homogeneous?
Can't know that.
How can you answer that? Yeah.
Well, you can. I mean, yeah, in a hypothetical scenario with nothing changing, with no sun and moon coming out and no cycles going on, and you had a container that happened to be the size of what they claim a sphere Earth would be, would it eventually reach equilibrium if all things were equal? Well, yeah, it would eventually reach equilibrium. The gas would just bounce around indefinitely at the same pressure. But that is definitely not the number one. The heliocentric world doesn't have a container the size of the Earth. It's just got gas next to a vacuum not expanding.
Okay. Oh, thank you for answering my question. This fixed the big problem that I had because I couldn't answer the question of why there was, lower air pressure at the higher tops of the mountain. So what I learned before was it was because of it's hotter at the ground level, and if it's hotter, there's more air bouncing around that would increase the pressure at the ground level.
Not really. It's more that the gases are produced at ground level. The easiest one to reference is the water cycle. Also, in so doing, you highlight the cyclical nature, the fact that it's a dynamic system in a cycle, if you use the water cycle as an example. So the gas is created at ground level and makes its way up. Just that simple. Well, obviously, if there's a high concentration of gas at the production point, it's going to get lower as it spreads out to fill the availability of volume. Now, it doesn't reach equilibrium, it cycles back down again as rain.
Oh, okay.
Right, and also there's the temperature influence, which is pretty much all at ground level. That's where the heat comes in.
I think temperature is a good explanation for the gradient.
Okay, so it's technically both. It's the gases being produced and the temperature, right?
Well, you could describe that as a cause of the gas production in the first place in the case of the water cycle. The water gets heated up when the sun comes out, so you could directly ascribe that as the cause. But you're ascribing a cause of entropy in terms of what's causing an entropy increase, as opposed to the cause of entropy. So you're saying in this instance, the sun is an entropy generator. Well, yeah, that's true. It's not saying that the sun is the cause of entropy, though, just to make that clear. I know you didn't ask, but just don't want any comments about it. Did you say the sun causes entropy? Well, no, the sun can cause an entropy increase, just to get that clear.
Yeah, thanks for answering my question. I appreciate it.
Pleasure. Any evidence that you can have gas pressure without the necessary antecedent of a container to press upon?
Absolutely not.
No.
We made that up, Nathan. We made
There's
it
a
up
lot
as
of things.
flat earthers.
Yeah, there's a lot of things we're told we make up. Entropy. Made that up. Begging the question? Made it up.
No, we figured it out.
Any evidence of the distance to the sun?
What is the sun?
A black body.
Can we have a distance to the sun?
60%
Can we find
black.
out
I
what it
found
is
that
first?
quite offensive.
Nathan, can I ask you about the ether?
What's ether?
The background medium
Oh
of like
my
where light is
God, here
produced.
we go.
Sorry, background medium?
The
What?
ether.
Yeah, the ether.
What does
Do
this
you know anything
medium,
about it or no?
what does this medium consist of?
It's just like the universal background. It's like light's not like a particle. It's actually a propagation through the ether. Do you know what that is?
Says who?
Oh, that's
Oh,
an
yeah.
ether.
Hold on, Arwin. Bloody hell.
The quantum field.
Yeah, it's like the universal background of everything.
The quantum field. You may as well
Yes,
just
yeah.
say
Hello.
quantum
Says
field.
who? Who's saying that there's a background field called ether that you need light to
Michelson
propagate
Morley.
through? Nicholson Morley. All right.
Yeah.
With what?
The experiment. I forget what the experiment was called. I was just wondering if you knew anything about it because I had a
Nicholson
couple
Morley
questions about
experiment?
it. Yeah.
You tell me. How does this prove there's a background medium?
So basically, they were trying to measure. It was called the ether wind, right? If they were, they had like a light panel, and they were trying to measure if they moved, if they shot waves through the panel and they also moved the panel, would it contract the wavelengths, right? So what Einstein tried to do is he tried to explain this away. He says this was time dilation. The light waves arrived later, right? And this is basically where the theory of relativity came from, special relativity, right? It was to explain the way this experiment, right? But what was actually going on is it was experienced ether wind. The light was moving through the background medium, and the wave was contracting, right? So the reason why they said this was contracting is obviously because the time dilation, but and the reason why this apparently debunked the ether was because their claim
Guys,
they were assuming
who's
that
doing that? Hold on a second, my friend. Hold on. Who's doing that? Who's opening their mic and just making loud noises from G+? It's really irritating. Go ahead, my friend.
Okay, so basically, their claim was that the Earth was already spinning. That means we should always experience an ether wind, right? So this, they said that the experiment was debunked, therefore there is no ether, right? So now they brought up the idea that light is a wave and a particle, and since light is a particle, it has to be affected by gravity. And this would explain and the speed of light, right? They would explain away, why the planets are millions of miles away.
Okay,
It's
there's
because
quite a
the
lot to
light waves
digest.
are,
Hold on. Get too much to digest. So, what's ether?
It's the universal background. Since light is
you said that.
So
You said that.
a wave.
Yeah.
Sorry,
You've had all this. Okay, if you're just going to repeat what you've said, fine. I'll start taking it apart. No problem. Yeah. Okay. So, do you understand the difference between science and experiment, and pseudoscience and just so stories?
Mm-hmm. Yeah, I agree.
Oh, agree? It wasn't an agree or disagree question.
No, I know what the difference is. Yeah.
Okay, what's the difference?
Science is observable, repeatable, and provable. Pseudoscience is none of those.
Observable what?
Observable, provable, and repeatable.
So if I observe the speaker in front of me, and then I close my eyes, and then I open them, and then it's there again, is that a scientific experiment then? Because it's repeatable and observable. So that would make it science, right? By that standard?
Mm-hmm.
No. Most definitely not. So do you want to try again? You don't know what science is.
What do you mean?
I mean, you've got it wrong.
Okay, so what are you trying to get at then?
I'm trying to say that you're trying to explain away and argue within narratives of pseudoscience that aren't explaining things with science, but you're ascribing these terms like experiment to the Michelson and Morley contraption.
Mm-hmm.
You've also reified a probability distribution derivation into wavelength into something that actually requires a medium to propagate through. So, no, light definitely is not a wave, but you've reified this derivation of wave function into wavelength and then decided that it is actually a physical wave. It isn't. That's wrong. But let's start with the Michelson and Morley ether nonsense first. So based on the notion that light is a wave, it would require a medium to propagate through. Light isn't a wave, and it doesn't require a medium to propagate through. There is no.
So what is it?
There is no ether necessity for light to propagate through. That's just not needed.
So what is light then?
Can,
I don't know. It's a very
can
good
I
question.
also put something, Nathan?
Go ahead.
Because I thought it was also very odd that it would be suggested that this assumed wave medium, like how can you have a wind of the medium of light when it's just a medium? Isn't it a wind of light? Is it a wind of just the whole thing was so convoluted. I don't even understand what is claimed.
Sure, but it all starts with an assumption that's incorrect in terms of the derivation from probability distribution, mathematics, to wavelengths, to actual waves. That's what his journey's taken him along. And then with that assumption in mind, which is incorrect, a necessity for a medium for the light, which is a wave in his idea of what light is, to propagate through. That isn't the case. There is no need for an ether. It is not required. And the validity offered for ether is the Michelson-Morley quote experiment. That's where we're at so far, Arwin. I was hoping to next go through why it's not an experiment with this chap, because it's useful to know. Arwin, did you want to add anything else?
Yeah, I agree. I was just really puzzled because it seems discontorted even within the presuppositional formulation of it.
Oh, it's a total clusterfuck. Don't get me wrong. No offence, my friend. Calling it a nonsense is going to hopefully become clear why in a minute. So, your apprehensions about what science are. Science is just a method, and the method has a very specific purpose. It's to establish the cause of an effect. Now, an effect, in scientific terms, is a phenomena. Now, it has to be natural, because if it's not natural, it's synthetic or man-made, and you already know the cause of that, and man made it. So science is exclusively interested in natural phenomena. Science deals with the physical, physics, and natural world. Yeah? So natural phenomena, effects, is what science studies. You with me so far?
Yes.
Okay. So that's the first question you need to ask yourself if something's claimed to be science or an experiment. We'll get to that later. But in this case, it's claimed to be an experiment. Well, an experiment is the actualization of a hypothesis. And all a hypothesis is what I described science as being. Establishment of cause and effect. So all a hypothesis is what you think the cause of the effect you're studying is. That's all a hypothesis is. It's really simple. It does have a slight complication in it has something that makes science empirical, a null, the opposite of what you think the cause of the effect will be. So if you think A causes B, a null is A doesn't cause B. Yeah? That's a null hypothesis, but that's an aside. For now, all you need to know is that science is studying phenomena, things that happen in nature, and all a hypothesis is what you think causes the phenomena. That's it. That's all a hypothesis is. So when we come to that knowledge established with you now, hopefully, I'm not going to ask you to nod along. Ask yourself this. In Michelson and Morley, the experiment that is, in quotes, what's the phenomena that they are studying for it to be an experiment? So I'll ask you, what's the studied phenomena?
They're studying how light works.
So not ether then.
Well, no. So the experiment apparently proved the ether.
But you just said that the... Sorry. No. Just the cause and the effect. That's all that science has in the hypothesis. Not extraneous stuff. All that is held constant. So all you're looking at is the effect. What are you studying? You've said light. So we're studying light. And we're going to figure out cause of certain aspects of light. Yeah? Now, unless you're going to say the cause is ether, is that the case?
I would say for the drift, yeah. For the
Perfect.
contraction of the wavelength.
Okay,
yeah.
so we seem to have a hypothesis, right? If ether, then ether drag, I think is the term.
Yeah, your ether wind.
Okay. So we've gone from light to ether wind. So what we're doing is we're changing the phenomena now. You said it was light. Now you're saying the phenomena is ether wind. Now, is that going to be the cause of the effect? Because if so, the next thing we need to do to establish it is actually causing the effect. Effect being light in this instance, a behavior of light. But then you need to actually vary the thing you cause the effect with in your hypothesis. So in this instance, if you're saying this effect of light witnessed as a phenomena apparently in this man-made gizmo, I'm not sure where this is happening in nature, but we'll come to that later. But the light that's happening in this man-made gizmo is apparently caused by ether wind. So how do you vary that which you assume causes the effect? How do you manipulate it to show it does cause it? How do you manipulate ether?
Okay, so we have two light panels, and one is stationary and one is moving. The one that is moving is experiencing a wave contraction. Therefore, that would be the ether wind.
Sorry, and you're varying the ether wind when you're describing little pieces of metal. You're not varying that which you can assume is your effect in this instance, and the effect isn't a natural phenomena. So you're not varying ether. Yeah? You're saying I'm varying the contracting light as I spin a wheel? Well,
the ether is the explanation.
That's not varying ether, though, is it?
No, it's not varying the ether. It's varying.
Right. So in an experiment, all you're trying to do is establish the cause of the effect. What you vary can be validated or invalidated as the cause. And when you say, no, I'm not varying that which I assume causes the effect, do you see how this isn't science? And the effect is a man-made device, isn't natural. Again, this isn't science. This is most definitely pseudoscience. Creating an effect within a machine and then supposing that something you are not varying, that would be ether, is the cause in some instance. You're not varying it, you're varying how something moves on a dolly. And
so
you're not got a natural phenomena.
Wave contraction?
Pardon?
What's the explanation for the wave contraction then?
Where do we observe that in nature?
What do you mean?
I mean, science deals with the natural world, physical natural world. So for it to be a phenomena, first we must experience it in nature, for it to be a natural phenomena worthy of study. Because if it's not experienceable in nature, it's created by man. So do you want to direct me to where this happens in nature?
Well, in order to, we need a tool to experiment. We need a tool to test the wave contraction.
So what wave contraction? Where is it experienced in nature? Where are you going, oh, I wonder what caused that wave contraction? Where did that happen in nature?
I mean, it must happen all the time in nature if we observe it, right?
Where? Where am I observing this in nature?
I think everywhere.
Can I ask a question about this ether stuff?
Not until we establish where this natural phenomena is happening everywhere, and I'm not seeing any wave contraction. I'm sorry if I'm being stupid, but you say it's happening everywhere. I don't see it happening at all. I don't even know really what you're describing because I'm not looking at it now, and you're saying it happens everywhere? No. You haven't directed to me where this happens in nature. Are you going to assume it happens in nature and then go on and make a man-made device and say that that's a phenomenon you're studying because you assume it happens in nature and then you've recreated it in a man-made gizmo? Definitely isn't a natural phenomena. Do you see where I'm going with this, yeah?
Okay, but the tool that we use is what's picking it up. So obviously we can't see with our eyes, but we're using a tool to, you know.
Okay, and where's the
Picking
tool observing
it
it happen
up?
in nature?
The wave contraction, anytime you move the panel or like the light.
So when you move a man-made device, so you're still onto you can create this on a man-made device. So again, back to synthetic versus natural. You're creating it then. The man's making this effect happen then. You're making it happen. You're manifesting the effect by doing something. That's synthetic. The effect is synthetic. A man made it.
I mean, the thing to test it, yes.
Test what? What's naturally occurring that we need to test again? Test is an experiment.
So they're testing the wave contraction.
That's been made by man.
No, not the wave contraction that's being by man. It's the drift. So when the light is passing through just the medium, it's contracting, and there has to be an explanation of why it's contracting.
Again, why? Why do we have to explain this man-made gizmo that are man-made? It's not a natural phenomenon. This isn't physics. This is technology. It's nothing to do with your world and everything to do with how technology works. It's not science. You're under the impression that they're doing experiments. An experiment is a very specific thing. It's a hypothesis test. Yeah? Physics is science. Physical. Well, physically, we don't experience what you're describing in nature. So it becomes technology if you're saying we must know the answer. Well, yeah, you could say that about how a computer functions, but that's technology, not science. And science deals with the physical and natural world. That's what I'm interested in, not how technology works. I'm definitely not interested in technology that's then ascribed to this made-up cause for a misapprehension about light working through a medium. Ether, and then it's claimed to be the cause in this quasi-experiment, which it isn't, even though you're not varying it and manipulating it in any way, shape or form. It's claimed to be the cause of a man-made effect. It's all nonsense, meaningless nonsense.
There is a variable. It's the stationary one versus the one that's moving. The one that's moving is contracting the wavelength.
And where's this observed in nature?
Nathan,
Cool.
Everywhere. It's just you need a tool to test the contraction of the light.
So you
Nathan,
need a
my question
tool.
is very relevant to this.
Yeah. Not proving ether, number one. You're saying this proves ether. Well, number one, if you're varying the tool, then you're not varying ether. So you're not proving ether as a cause of anything.
No, we're not varying the ether. Where the explanation is the ether.
Yeah, no, an explanation would be the cause of the effect when experimenting. By varying the cause, that's how you validate your assumed cause. So you can assume the cause, but to validate it, you vary it and see if it causes it. You don't vary the distance or the spin or anything else and then say, actually, my variation of distance is ether. No, you have to vary ether. It has to be real. You have to actually be able to physically vary it and hold it. Physically. It's physics. Physical. So if you can't physically hold it and show me it being varied, it isn't real. So how can it be an independent variable cause of an effect if you can't show it me or vary it in any way? And telling me about some man-made gizmo you vary isn't you varying ether.
We're varying the light that's moving. That's what we're
So
varying.
not ether then.
No, the ether is the explanation of
No,
why.
that's your
things react.
assumed explanation. And in science, you vary that to validate it. You don't just assume it and move on and then argue about how Einstein's debunking your assumption you haven't validated or proven or shown in any way in any physical terms. For it to be physics, it's got to be physical.
So the reason why we have the theory of the ether is because waves experience contraction due to
Stop! No, you haven't got a theory. Stop using these terms. Stop. A theory comes after experimentation. Comes afterwards. First, natural phenomena. Then, hypothesis construction. Then, systematic experimentation. Then, theory. Comes after the experiment. You haven't got one. You haven't even got a phenomena. So don't tell me about the theory that you're explaining. Because if it's not a scientific theory, it's a mystic meg theory. A colloquial theory with no empiricism attached. And the empiricism, do you remember when I explained about the null? If A, then B, the alternative. If A, not B, the null. When you experiment, one or other of those outcomes gets validated. Either it is or isn't your assumed cause. So in your null, you'd have if ether, then wave contract, then not wave contraction. And then your alternative would have to be if ether, wave contraction. So then you vary ether and see if it causes the effect that you haven't observed in nature. That's how you empirically validate the cause. You don't say, well, I'm varying the distance between the... and then actually the cause of it's ether. That's not how it works. To be science, you've got to validate it empirically. And the empiricism comes from the null. The null is the antithesis of your assumed cause. And when you vary your assumed cause, either it causes it, validating the alternative hypothesis, or it doesn't cause it, validating the null. So one of them gets validated at the end of the experiment. Either it is the cause or it isn't the cause. Only one can stand true, but you haven't even got the bloody ether to vary. Just making up stuff and saying that's the cause. It's not science, it's pseudoscience.
So what is the explanation for the wave contraction then?
What, the man-made device? A man made it.
No, the device is testing it.
Yeah, unless you can show it me in nature, a man made it.
No, the observed phenomenon is in nature. Is the device is testing it.
Sorry, where's it observed in nature? You just keep assuming it happens everywhere. I asked you last time, 3 times you told me everywhere. I explained in detail that it's not happening everywhere. I'm not seeing it happen. You haven't elaborated and said, no, under a microscope, you'd see X happening. And the happening is the phenomena. It's an occurrence. So what occurrence do I see everywhere? Well, it's just assumed to be everywhere. That's what you've told me. Well, no, mate. This isn't my first rodeo. There is no ether. You don't have to like it. If there was, you could just show it me and then vary it. But you can't because it isn't real. And this is obviously triggering. You can't show it me.
Yeah, because you're rejecting the device.
Why do you keep saying that? Why do you keep saying that?
Sorry, I'm rejecting a device. That's not a phenomenon.
Yes,
it's not
you need a device to test it.
It's not a phenomena you've studied. The apparatus is irrelevant. Doesn't matter. You can use whatever you like to test a phenomena, but the apparatus isn't the phenomena.
But how do you know it even exists without this device? Where do you see it?
Obviously, you can't see a wave contraction with your eyes.
So then how do you know it exists?
That's why you need a device to test it.
No, you're inducing it with a man-made device. You're saying we don't experience it in nature, but if I create a device, I can induce it. So you've made that happen. A man made it happen. How many times?
But how do you know that?
Because a man made it. You're telling me Michelson and Morley just, the apparatus just fabricated itself out of sand by way of nature, or did a man make it? I'm pretty sure, given that they put their names on it, that a man made it. Hello? I know a man made it. I already know the cause.
Well, why would you manipulate a cause to an effect and then claim that that cause is something else that you didn't manipulate? Why would you do that?
He's got a belief in ether.
What's that?
I think he left.
All right. Yeah, that's going to happen. If you've got a faith and it's getting ripped apart. Maybe he'll rejoin me. You have technical issues. We'll give him the benefit of the doubt. We won't claim rage quit.
So, somebody did rejoin. I don't know if that's him.
That's okay. I thought it might just be a glitch. Anyway.
What?
So, ether. Waves of it. How does waves of ether?
Why does everybody want this universal
That still was
background?
never answered, you know.
There is no ether.
Hey, good morning, guys.
Say again?
Bro, I'm a globe earther, and
I
even I
just
didn't
want to know,
understand
like,
that.
how they thought
Oh,
they
and
were
open your eyes, it's
measuring waves
everywhere.
of ether or something. Like, I want to understand the thought behind it.
We heard the first time, Arwin. Go ahead.
I think he said waves of light.
Say again?
I think he said light was like a wave or something.
No, that's not a wave.
I just want to know if
I don't
this
know. I
ether,
just think that's what he said.
Go ahead, glitch.
Oh, I'm saying that I don't know if it is. I'm just saying that's what he said. Or at least I think that's what he said.
Yeah, he needs a medium because he presumes that light's a wave when it isn't. That's correct. Go ahead, Paul.
I've asked this question, and that's why this is the question I was going to ask, is the ether material immaterial? And usually when they answer the question, they start saying it's immaterial. So if it's immaterial, that means it's not physical. So how can you do any measurement on it if it's not physical? And I know that's kind of where you're going. I'm just trying to make it quick and
No, well
concise.
summarised,
So if
Paul.
it's physical
Yeah,
thing,
precisely. Well summarized. If they're
I
going to
think-
say it's an immaterial medium, it's like, well, then you can't deal with it in physics because that deals with physical.
Yeah, it's there for physicality supposedly to manifest into. It's what allows physicality to manifest, but therefore, by its own definition, it's not physical. It's
That's like
described.
Sounds like a god substitute.
Yeah. Well,
I
Am I
still
wrong?
don't understand how
Like
you can have
magnetism too,
waves
in
of a
ways.
medium.
it's not so much well, it is a god substitute, isn't it? Because it is that Owen, it's that wave. We've got this thing that we've conjured, but we've conjured it all the same, and we cannot explain it. What we've got is physical understanding of waves and things that we won't go into the detail of light waves, but we've got this physical understanding of waves, and it kind of matches our physical understanding of what could be going off, even though we it's not physical and we declare it's not physical. We then say, well, that's enough to declare that this medium is semi-physical, because must do that, because then it explains why I'm seeing this thing in this man-made thing.
Yeah, they need medium patterns for their wave patterns.
Well,
Well,
that's the
something
assumptive jump, isn't it? That wave pattern, yeah, means physicality in a non-physical dimension.
Something he said that I don't think he realized he said was, well, how do we explain it then? Well, if you have an explanation without a hypothesis, you just got a neat story, just poetry.
Yeah, be
I
careful.
don't think he's doing
A
that.
hypothesis isn't an explanation. It's a supposition.
Right, but you need the hypothesis first before you can move into explanation.
Yeah. Once you've validated an alternative hypothesis, you have the explanation for the cause of an effect you were studying. But prior to that, you have a supposition of an explanation. But it isn't even that, because you've got a null in there. So it's got the contrapositive alongside it. So you can't say it's a supposition of the explanation, because you've got the antithesis right next to it.
For all that, you need an observation.
That's the most important detail here. First step, what's the effect we're observing?
Hold on, let's create a device and we'll bring that up for you real quick.
And again, it's a misapprehension when you describe what they're studying, even in the apparatus itself. They've got a misapprehension about what wavelength is and it being physically shortened. And it's like, no, even if you've got a medium, sound doesn't do that either. Now, it's described on paper with wavelengths and frequency, but that is not how sound propagates, and it certainly isn't how light propagates. It's not a wave. Now, taking explanations for what we call wavelength in weight is derived from the probability distribution based on diffraction of light, where you can then scale that up for all the different, what we now call wavelengths. Again, it doesn't mean light's a wave. It's not called a wave. You're describing wavelength in that instance. But it's not saying that it's got a medium to propagate through. Same with wave function, where this all begins. But again, you don't need a medium for a probability distribution. It's just absurd. Hey, Brian.
Hey Nathan, hey lads. I'm going to be kind of driving, so I'm just joining in just to be listening.
I did about a week of plugging your channel. Did you grow much?
Yeah, I did actually. I'm getting new subscribers every day now. YouTube blocking how much I grow, because I've noticed I had more subscribers, then suddenly I had less in the space of an hour. I lost about 40 subscribers. This kind of stuff with YouTube, so there's that stuff going on. But I have constantly people subscribing, so thanks Nathan for that. I really appreciate it.
It's a pleasure. We've got to internally promote each other. There's no other way of growing, as far as I can tell.
No, definitely not. And even when we're doing that, we're getting subscribers taken away from us by YouTube, you know. Because I know of a man, I know of at least one, I think actually 2 people that had to subscribe to me 3 times. I mean, who am I? Do you know what I mean? Why should they have to do that? It's crazy. But what can you do?
Yeah, I don't know. It could just be trolls subbing you up just so they can unsub you when you get to a round number. That happens quite a lot to me. Anyway, sorry, start that again. Godzilla37, thank you very much first and foremost for the super chat. Poor ballers in chat, all so sure and too afraid to join the Discord. Ha ha ha, typical. Thank you very much for the super chat, Godzilla.
Michelson Morley, sort of like the Cavendish for flat earthers, or some flat earthers.
Agreed.
That's correct.
Yeah, I agree. It's a bit of pseudoscience, and it doesn't matter if you point out to flat earthers that it's pseudoscience. There's an unfortunate group of people that want to retain that magic trick, and that's all it is. A magic trick that takes an empirical method that can be asserted with dogged assurance that what you say with the word of science attached is right. So they've done an experiment, another part of that vocabulary. Okay, well, it must be empirical then. No, they've just hijacked the wording. They've just called what they call a test when they create some technology. They've called that science, and it isn't. Well, they've just taken an empirical method and made up a just so story based on something that they've created from scrap. And they've called it something that validates your world when they just invent a story about a medium for light to propagate through when light isn't a wave. So it's just a whole big fat steaming pile as far as I can see. And loads of flat earthers buy into it. No idea why, I don't know. It's presumably been punted out with the controlled up narrative that we all got subject to when we first came to this subject, right?
Science, it must be natural then, right? Must be observed. Why can't anybody say where we could go see this ether thing? Wherever the hell it is, without having to create a device first. Nobody can give me an address where I could go see ether?
Not a thing. It's not real.
Yeah, that's the problem.
Why do we need it? I don't understand. This is something that's I can't fathom. It's like, okay, I get what it is. It seems to be a substitute for space. What do you need it for? Why do you need a substitute for space again?
What space? Vacuum space?
Yeah, the vacuum of space.
If it doesn't exist, why would we need a substitute?
Precisely. That's what I can't fathom. There is no sky vacuum. What are you talking about? Oh, well, what was formerly the sky vacuum, am I going to turn into ether? Why? Well, because we need a medium. Why? We need containment to be breathing, critically. Well, beyond that, what do you mean light needs a medium? No, it doesn't. Yeah, it does because it's a wave. No, it isn't. And so you go on.
I think certainly the heart of ether, that question wasn't settled, Mason, in terms of particle or wave. And a lot of the explanations for ether help satisfy wave behavior. Back in the day would probably help you or understand the nature and the behavior of light with it. Obviously, it has the associated baggage now. I think from my understanding, there's no direct need for it, but I can understand in the 1800s why it was. Is it phlogiston as well? Well, there was lots of these things where we put the issues that we don't understand, and for able to progress, we stick it in that box and kind of carry on, calling it ether, calling it phlogiston, whatever it is, until we do get an explanation. And I think in relation to light and ether, we've kind of got that explanation now. That's not to say there aren't
kind of like dark matter.
Yeah, exactly, Chocolate. Exactly.
Well, it's an aberration.
Let's create this because our what we say gravity is doesn't actually work in the universe that we know of. So let's create this dark matter, which explains it all.
If you call it ether, it makes me toast cold because it has a connotation that you have an understanding of what it is. If we just refer to it as this effect that is generated that we have no idea why, or we cannot explain yet, then that's actually the reality. There's no need to assign a medium, another dimension, or anything to put it in. Surely it's sufficient that we don't understand it, to the point that it's a bit weak that we invent an imaginary thing, like you said, like dark matter, just something to fill the void, to pretend we don't have an understanding. Nothing wrong with saying you don't know.
Can you hear me now?
Yeah.
Okay, so right when I was talking, I lost the internet connection, so I'm back. So I was saying, I
Damn
thought Paul's
satellites.
point. Yeah, they just fail right when you need them. Paul was saying, is it immaterial or is it material? And as I was listening to the caller, I think he was thinking, hey, we use I mean, this is my words, but this is the correlation I'm making. He was thinking that the apparatus was finding something. Now, he's probably thinking, look, we use microscopes to see smaller things that we can't see with the naked eye. But that's where Paul's point really is good, because are we looking for something material or immaterial? Well, if it's immaterial, you're never going to see it, even with a microscope. So I think he was stuck with using tools that actually do allow us, like a microscope, to see things that we can't see with the naked eye, which are material. And he's applying it to, well, why can't this be looked upon the same way? Well, if it's immaterial, you haven't observed it and you can't see it, then how are you ever going to see it?
Well, when you look at the diffraction grating, all you got to do is assert a cause for it and say light is like a liquid. But then you say perturbation of the ether. That way you're not really directly tying it into a medium. And you just got to get real fancy with your words, you know.
But there's a problem.
Tiptoe.
Perturbation of the what?
Yeah. You've got to actually have the pattern first, right? Well, if you fire off particles of light one at a time, you can still, if you know what light you're firing off, still calculate all of those distributions. But you've only got one hit on the photographic plate or the sensor. So you haven't got anything to even describe as a wave function at that point. But light still travelled from A to B. I'll carefully phrase that. maybe not. Anyway, the point is, you've got one hit on the photographic plate. You fired light. You knew what it was. You've already done the maths because you've done it 20 times before. But you've still only got one hit on the photographic plate. Where's your wave?
Well, even worse than that, this supposed wave function disappears when observed, right? So, or when the path is known, I'm sorry. When the path's known, it disappears. So it couldn't have been a wave to begin with and then just stop being a wave.
Well, the same thing happens if you know the path, right? You fire one, you get one hit. The only difference in those two scenarios, no waves involved, no patterns that could be described as waves, no travel through any medium that was wave-like in any way, shape or form. Just one hit going through a double slit when you know which one it is, and therefore you know where it's going to hit on the photographic plate, that one instance, and you get one hit and you mark it and you go, I knew it was going to hit there because I knew which slit it went through. Or you fire one when you don't know which slit it's going to go through, and it goes somewhere based on probability, you don't know where it's going to go. It's likely to go to the middle one. It's got this percentage of chance of going to the middle one. But you fire it, and what do you know? It goes all the way to the left. Because it's just a probability. At the end of the day, you've only got a probability of knowing where it's going to hit. You don't know where it's going to hit. That's the point. But you've still only fired one through the double slit, and it's only impacted once. There's nothing in that to describe as a wave, is there? Zero.
Exactly.
Well, you know, if you really wanted to get more detailed about it, then you'd have to follow the presumed path of the light particle, or however you're going to regard it, as it basically moves out of the slit and then see if it actually moves in accordance to a wave-like motion, or is it just going in a straight line? And exactly as is said with the distribution probability, it just has a pattern to how it moves in a straight line beyond the slit, to clear it up. Because if you realize it's all going in a straight line beyond the slit, there is no wave. Not really. It has nothing to do with the wave.
Let's apply my question to the wave. I want to apply my question to the wave. Is the wave physical?
What wave?
Or is it material
What
and
wave?
material?
What wave? When I say I've fired one through a double slit and it impacts once, you can only derive a wave function if you've got multiple hits when you don't know the outcome. It's diffraction, right? You've got the interference pattern, but it's a pattern. In other words, you can fire one particle at a time until it builds that pattern, and you can then work out your probability distribution based on the pattern that's appeared. But you've got to have the pattern, right? You've got to have multiple impacts to work that pattern out as a diffraction pattern, otherwise known as a wave function or probability distribution. You've got to have lots and lots and lots and lots of impacts to calculate that, to see it as a diffraction pattern, which is reified into a wave. But what about when you've only got one?
Yeah, that's what I was.
One hit. There is no. You're asking where's the wave? Well, if you've only got one hit, there's nothing to be described wave-like in any instance whatsoever.
Indeed, there's only an angular deviation pattern.
All right, go ahead. Discord.
Wouldn't that be akin to comparing a wave like a giant mass of water that allows waves to occur versus a single droplet of water? Now, there obviously wouldn't be a single droplet of water showing a wave pattern or any kind of wave behavior. So going to a single photon is like just taking a single droplet of water. You're not going to get the wave dispersion effect.
Well, sure. If you want to compare it to waves, which Adam tried to do last time, and I don't get it because it just confuses things, but I'll try and do it with your example. If you imagine the wave that's being reified in the medium is going to be the waves of the ocean, well, the impact of each photon is more akin to the pattern and probability of each impact of the crest of the wave when it hits the beach. So when the wave hits the beach, it leaves a mark. But then the next wave comes in and it doesn't hit the exact same spot. It's further down the beach. And then the next wave comes in and it's further up the beach. And eventually each of those impacts, not of the medium, the wave is irrelevant. It's just the thing that's creating the impacts on the beach. Well, the probability of where those impacts on the beach lie could be calculated as a wave function. Yeah? By analogy, it's pretty sloppy. But I'm just saying, in other words, what you'd be studying to give you this probability distribution is the probability distribution of where the wave impacts the beach. In other words, the wave itself is completely irrelevant. Nothing to do with the medium and everything to do with the frequency or the impact rate and when it's going to come. The probability or likelihood that the next wave's going to impact here, 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 or here. And that probability is that mathematical term, wave function. The probability distribution. That's what wave function is. The likelihood of each impact, where it's going to be next. Not waves. Not a medium. Nothing to do with anything of the sort.
Good point.
Anyone else want to add anything on this?
Well, if you can supposedly collapse a wave function of light, if you assume it's light actually being a wave, doesn't really matter. If you can collapse it practically out there, can you demonstrate the same effect with some other form of wave that's actually a wave? I don't think so.
No. Yeah, that's a good point. I was just about to round out the live show, but I will just strap that on to the end of this live show before I round out. So let's just press a few buttons so I'm not going to accidentally roll an outro. But yeah, exactly. So if you're talking about wave function collapse, what you're talking about is when the light gets fired through the double slit, whereas I've described up until now not knowing where it's going to hit on the sensor or the photographic plate. It could hit here, it could hit there. You don't know. You've just got a probability of where it might hit. Each time you fire it, you say, oh, I know for certain it's going to hit in the middle this time, and what do you know? It doesn't. It hits far left. So it's a distribution of probability. You don't know where it's going to hit next. Now, wave function collapse is just you then knowing which of the two slits it went through in this example. And then because you know, it only hits behind that slit. In other words, you've got two slits, therefore you've got two lines. If it goes through the one slit, it makes one line of impacts. And if it goes through the other slit, it's got another line. Well, that is the collapse of probability to actualization. It actually goes through this slit and actually hits behind it. And I know because I knew which slit it went through. So I knew exactly where it would end up on the photographic plate or on the sensor. Well, that's because it's gone from a probability, wave function, to actually knowing where it's going. You know which slit it's gone through. But that's the difference between not knowing something, only having a guess or a probability of likelihood, to actualization. I know which one it's going to hit because I know which slit it's going through. That's wave function collapse. And again, with that fairly lengthy explanation of a mathematical description of probability to actualization, are you going to turn that into a wave, like an actual physical medium wave, like at the beach? Are you going to do that now? It's absolutely absurd. You can't. It's nonsense to even try. Any more? Any more for any more?
Well, you could potentially try to emulate this setup by having two slits in a body of water and then creating little waves specifically behind either slit, right?
No,
It sounds really sloppy, but it could be done. Who knows what'll come out of it? But I'm pretty sure that if you know which behind which slit the push on the water is going to be caused, it's still going to ripple out every single time.
Trust Darwin to descend it into nonsense. With that, I'm going to say a huge, massive, enormous thank you to both Discord and G+ panels for making today's live show possible. Also, a massive thank you to all of you who smashed the super chat. If you are watching this on either Nathan Oakley 1980 or Nathan Oakley premiering stream, stay tuned as there will be an after show to follow. I have been Nathan Oakley and I'll see you all in the next video.
What a lovely day!